Hello everyone and welcome back to the channel. So guys, in this video we are going to cover a further React.js interview question. So if you are new to the video and if you are new to the channel, please make sure to subscribe to the channel and also make sure that you watch the previous video where I have covered 10 detailed questions on React.js interview. Now this is a continuation video and in this video we are going to cover further more interview questions. So let's get started with first question for today. So the first question for today is, what is the difference between HTML and React event handling? So basically we have event handling, right, in HTML also and in React also. So we have to tell the major difference between them. This is very common interview question that is being asked in React interviews. So let's see the answer for it. So in React, below are some of the main differences between HTML and React event handling. So basically we are going to see three differences. So the first one is, in HTML, the event name usually represents in lowercase as a convention. So for example, in this case, you can see on click how we have written, whereas in React, it follows camel case convention. So if I say, like in HTML, if I have to write the event handler on click, I'm going to write it like this. Okay. Everything is going to be in small case, but if I have to write it in React, I'm going to write it in this way, on click. This is camel case convention and this is lowercase. So this is the main first difference. Let's see the next difference. The second difference is, in HTML, you can return false to prevent the default behavior. So, like in this case, let's see this example. We have a function handle click, which is taking an event. So what we are doing is event.prevent default. Okay. So, so basically this example is of React. Okay. And this example is of HTML. Okay, the screenshots are like swapped. So just consider that this example is of React and this is for HTML. So let's see the firstly, let's see for HTML. So in HTML, if we have to prevent the default behavior, what we are going to do is we are going to return a false, right, in this way. But in React, what we do is we use event.prevent default. So this, what it will do is it will prevent the default behavior. Okay, so in order to prevent the default behavior, we use event.prevent default in React, whereas in HTML we return false. So just remember that thing. Now let's see the third difference. In React, like what we do is we do not invoke a function by appending these brackets, whereas in HTML we have to append the brackets. So for example, we have an on-click event handler which is calling a function active lasers. So we have to append the function name with this brackets, whereas in React we directly write the function name. So this is the third difference, you can say. So we have seen total three difference. So first one was like casing, camel case convention follows in React. Second one was this one, where like it prevents the default behavior by event.prevent default, and the third one is invoking function using bracket, right, in HTML, and in React we do it directly. So these were the three difference, and this was one of the main important interview question. Let's move on to the next question, which is, what are inline conditional expressions? So this question is very important in, like, even in terms of interview also and in terms of your normal project building also, because we usually use this concept when we build our projects. So let's see what is this. So you can either use if statements or ternary expressions, which are available from JavaScript to conditionally render expressions. Apart from these approaches, you can also embed any expression in JSX by wrapping them in curly braces and then followed by JS logical operator end. So let's see. So for example, in this case, what we are having is, we are first of all having a heading hello, and then we are having a messages. So we are checking if messages.length is greater than 0, then only the further code should get executed. Okay. So if this part is true, then only the further code will be executed. And then again, it is checking one more condition, that if is logging is false, okay, which means like not of is login means if is login is false, then do this, execute this code which is after the question mark, else do this. So we know, right, what is the what is the syntax for this ternary operator. So what basically we do is we write the condition here, okay, and then we write a question mark. So if the condition is true, then this code will execute, and then we have this colon. So if the condition is false, then else part. So basically this is the if part, and this is the else part in this case, right? And if additionally, if we want to put one more check when the particular code should only execute when a condition is true, then we can also do something like this, which is end. So that is what we have written here. Apart from these approaches, you can also embed an expression in JSX by wrapping them in curly braces and then followed by JS logical operator end. So this is what inline conditional expression. So what we are doing is we are writing conditions within a single line. Okay. So this is called as inline conditional expression, because if when we write if else, it is called as a statement, and writing this way is called as conditional expression. This is not a statement, this is an expression. Moving on to the next question, which is what is keyprop and what is the benefit of using it in arrays of element? Again, one of the most important question, because this is again very logical, and it even improves your performance of the app if you use keys. Okay, so let's see. A key is a special attribute you should include when mapping over the arrays to render the data. Keyprop helps React identify which items have changed, added, and removed. Okay, so React understands if you have added the key, it clearly understands which items are added, removed, or changed. Key should be unique. This is the most important point. Okay, the main purpose of adding keys is that it should be unique amongst its siblings. Most often we use ID from our data as the key. Okay, because ID is the unique, ID always has a unique value. So we usually use ID as a key value. So this is an example of how can we use keys. So here what we are doing is we are having a to do array. Okay, to do's array. So on that we are mapping. So every time we are taking one entry of an array and then we are displaying in a list. Okay, so and in the list we are using key. So if you see here, what we are doing is we are taking ID from the to do, which means the entry of our array. So you can consider something like this to do. This to do's is our array. Okay, and it has multiple entries. Okay, and it can be an array of object also. So for example, if it is an array of object, so it will have an ID and it will have your some like data or task or whatever you can say if it is to do list. So for example, your ID is 1 and your data is hello. So in this case, what you are doing is you are taking key as your to do.id. So in this first iteration, it will take ID as 1. Second iteration, it will take another ID, because we know that ID is unique. So in this way, when we add to do, when we add key, it improves the performance of our app, because React identifies what items have changed, added, or removed in your code. So this is the importance. Now let's see the next thing. When you don't have stable IDs for rendering items, you may use the item index as a key as the last resort. Okay, now this is very important, because you know not every time you will have ID along with you. Okay, suppose you might have data something wherein like you will have to do's array and you will just have data. Okay, like hello. In this case, you are not having ID. So what are you going to use? Okay, so if you do not have ID, so better than not using any key, it is always suggestible that you should use index as the last option. So if you don't have any unique value in your data, so you can use index. So what is basically index? So when you are iterating over your array, you can use this index, and then this index can be used as a key in this way. Okay, so you can do this key equals to index. So in this case, your index will be considered as a key, but index is not a better way of using as a key, because you know it has its own drawback. We'll see that in a minute now. So let's see the important notes about keyprop first of all. So using indexes for keys is not recommendable. Okay, you can clearly see here using indexes for keys is not recommended if the order of items may change. This can negatively impact the performance and may cause issues with component state. So if your order of items or your list is changing, then please do not consider using keys, because that can have negative impact. Second point is, if you extract list item as a separate component, then apply key on the list component instead of the li tag. So you know in most cases what happens is, instead of this li tag, people use list component itself. Okay, this is a custom component. So instead of applying this key on the li, so what happens is, like, this is your li component, and this way, and inside this you might also have some another tag or something. So you have to apply your key on this list component, okay, or the parent component. Third point is, there will be a warning message in the console if the key prop is not present on list item. So like in this case, if you are mapping over a array, okay, and if you have not added key in your code, then you will get a error message in your console. This is very important. So next is, the key attributes keeps the key attribute accepts either a string or number and internally convert it as a string type. So you can pass a string value or a integer value, it doesn't matter, but just make sure that it is unique. But at the end of the day, it internally converts integer also into a string only. Okay, so you have to remember that. And the last point is, don't generate the key on the fly, something like math.random. Okay, on the fly means when your code is executing, at that time only don't generate it. Why? Because the keys will never match up between re-renders and the DOM created every time. Because understand what is the main purpose of key is to make React understand what is the difference that has occurred in your code between your last render cycle and this new render, right? But if your key is only changing between your last render cycle and your new render cycle, then React cannot identify, because for React the key is only new. So even though your data was same in your last render cycle and the new render cycle, React will consider it as different only because your key itself is different. So that is what the last point is saying. Don't generate the key on the fly with something like mat.random, because most people do this because they thought that key should be unique. So let's generate a new key every time. But that is not the concept. You have to use a key which should be which should have the same value even in the different render cycles, so that then only React can recognize it. Okay, let's move on to the next question now, which is what is virtual DOM? The virtual DOM is an in-memory representation of the real DOM. The representation of a UI is kept in memory and synced with the real DOM. It is a step that happens between the render function being called and displaying of elements on the screen. This entire process is called as reconciliation. This is a very important question, first of all, because virtual DOM is one of the main features of React.js, I would say. And what happens is, basically, the simple answer is the virtual DOM is the in-memory representation, or you can say this is not actual representation of the DOM. Okay, so it is an in-memory representation of the DOM which helps UI to compare between the last and the current changes. Okay, you can say the previous and the current changes. It helps us to identify. Okay, so let's now move on to our next question, which is how virtual DOM works. Okay, so this is very important, because when you understand this question's answer, then only you understand the behind the scenes of React, how React works. Okay, so please pay attention. So first of all, let's see. So the virtual DOM works in 3 simple steps. Okay, we are dividing the working of virtual DOM in 3 simple steps. First one is, wherever any underlying data changes, the entire UI is re-rendered in the virtual DOM representation. You have to remember this, that the actual DOM is not getting re-rendered every time, but first of all, a virtual DOM representation of the actual DOM is created, and then the re-rendering happens on that virtual DOM. Okay, so for example, this is the browser and this is your virtual DOM. So according to your browser, a virtual DOM is created. Okay, then in the next step, what happens? Then the difference between the previous DOM representation and the new one is calculated. So for example, this is your virtual DOM and this is your real DOM. But so which means this is your current changes or new changes, you can see. Okay, new changes, and these were your previous changes. Okay, so what will happen is the virtual DOM is compared with the previous version of itself, and it will find out that this is the 2 nodes, or this is like a new change, right? Basically, so when it will see that okay, this is the new change, so virtual DOM, what it will do is it will do the calculations. Once the calculations are done, the real DOM will be updated with only the things that have actually changed. So if you see, the real DOM will be updated with only the changes. Okay, and it will not re-render. So when updating or re-rendering, it is not going to re-render these nodes again, because that is an extensive operation. We don't want to spend much time on doing the same thing which is already there. So but React.js takes care of this thing using virtual DOM, that it will only update the new changes and by comparing with the previous changes. Okay, so I hope now you have got. So this was the concept of virtual DOM. Let's move on to the next question. So the next question is, what is the difference between shadow DOM and virtual DOM? So this is again these kinds of confusing questions are usually asked to you, because you understand what is virtual DOM, but if you might have not heard any time about the word shadow DOM, you cannot answer this. So let's see the answer for this. The shadow DOM is a browser technology designed primarily for scoping variables and CSS in web components. So you just have to understand this, that shadow DOM is used for what? For CSS in web components. Okay, so basically shadow DOM is something you can consider that you have this actual DOM, right? So in the actual DOM you will have a shadow DOM, and inside this whatever the variables and CSS that you declare will be like totally bound in this box itself. Okay, and it will not be present here. So this is the main concept of shadow DOM. That is, shadow DOM is a browser technology designed primarily for scoping variables and CSS in web components, whereas we already have studied about the virtual DOM. The virtual DOM is a concept implemented by libraries in JavaScript on top of browser's API. Okay, so you can speak a lot about virtual DOM because we have already understood it, right? So basically you should understand what is virtual DOM and what is shadow DOM both. Let's move on to the next one, which is what is React Fiber? Another important question and a lot that is being asked in the interviews. Let's see the answer for this. So React Fiber is the new reconciliation engine or implementation of core algorithm in React version 16. The goal of React Fiber is to increase its suitability for areas like animation, layout, gestures, ability to pause, abort, or reuse work, and assign proper priority to different types of updates and new concurrency primitives. So let us understand first of all, because here when we say the answer in the initial only we are using the word reconciliation, right? So we have to understand what is meant by reconciliation. So again, reconciliation is related to virtual DOM only. So let's get back to that diagram of ours where we were discussing this. So you know what we were doing in this step is the new changes or your new your current virtual DOM. Okay, we can say that this is the current virtual DOM. It was compared with your previous virtual DOM, right? So this comparison of current and previous is called what? Is called as diffing mechanism. Okay, or you can even say that this is called as diffing algorithm. So you have to understand these words. Okay, this comparison between the current virtual DOM, that is the new virtual DOM, and the previous virtual DOM is called as diffing, and this updation of only the new changes on the UI or DOM is called as reconciliation. Okay, so basically whenever we were studying virtual DOM, at that time only these both points came inside it only. Okay, so basically when this comparison is happening, that is called as diffing, and then updating part is called as reconciliation. Okay, so now we know what is reconciliation. Let's move on and let's look at React Fiber. So React Fiber is a new reconciliation engine or re-implementation of core algorithm in React version 16. The goal of React Fiber is to increase its suitability for areas like animation, layout, gestures, ability to pause, abort, or reuse work. So if you understand, these are areas are like, you know, the smoothness or the performance is very important, because you know when animations happens, so a little bit of slight delay also can cause a lag. So it is very important that React Fiber is introduced to increase the suitability of these all of areas, and it assigns priority to different types of updates and new concurrency primitive. Let's read more about React Fiber so that we'll understand what it exactly is. Okay, so what React Fiber basically is doing is, it is doing three things. That is, first of all, improved rendering pipeline, second is incremental rendering, and third is better support for asynchronous rendering. Let's see one by one. Improved rendering pipeline means what? So React Fiber introduces a new reconciliation algorithm that allows React to pause and resume work on rendering update. This means that React can prioritize rendering updates more efficiently, resulting in smoother animations and better responsiveness. So let's consider this way, that you know, before React Fiber, the previous reconciliation algorithm that was there, that might not have this facility to pause and resume the work. Okay, because of what? Because of which, you know, the problem might have appeared is once the process has started, it will only it will stop only after completion basically. But this pause and resume feature, what it allows is, it allows in prioritization of tasks, so that you know like the changes are asynchronous, they are like happening all together and simultaneously, which improves the overall performance of your app. Let's see the second point, which is incremental rendering. With React Fiber, rendering can be broken down into some smaller units called as fibers. This is very important, okay, because this is only giving the term React Fiber. Okay, so with React Fiber, rendering can be broken down into smaller units, which is called as fibers. These fibers can be prioritized and scheduled more intelligently, allowing React to work on rendering updates incrementally. This incremental rendering approach enables React to respond to user interactions more quickly and maintain a smooth user experience even when performing heavy computation or rendering large lists. So basically, let's consider this way. So you have a task that will be broken down into different fibers, okay, and these fibers are prioritized to schedule. Okay, so for example, this fiber is more prioritized than this one, so this will be executed first and then later on this will be executed. Previously, what would have been the scenario? If this entire task is getting scheduled, it will be scheduled completely and then only it will stop. So in this way, like, you know, when we prioritize task, the one which is more important should be prioritized first and then the later on. So in this way, the overall performance increases. That is what we have discussed here. So again, you have to understand this, that React Fiber, with React Fiber, rendering work can be broken down into smaller units, which is called as fibers. These fibers can be prioritized and scheduled more intelligently, allowing React to work on rendering updates incrementally. This incremental rendering approach enables React to respond to user interaction more quickly and maintains a smooth user experience even when performing heavy computation or rendering large lists. Third point is better support for asynchronous rendering. React Fiber provides better support for asynchronous rendering tasks, allowing components update asynchronously without blocking the main UI thread. This helps prevent the UI from freezing or becoming unresponsive during the rendering updates, resulting in more fluid user experience. So asynchronous rendering is also important because, you know, it helps to prevent the UI from freezing or becoming unresponsive. So these are, if you know these 3 points about React Fiber, you know sufficient. You have sufficient content to explain to the interviewer. Let's move on and let's see what is the next question. So the next question is the same, like what is the main goal of React Fiber? So if you are asked what are the actual goals of React Fiber, you can say it in this way. First is ability to split interruptible work into chunks. So if there is a bigger work, then it can be divided into chunks. Okay. Next is ability to prioritize, rebase and reuse work in progress. So we have already seen that it has the ability to prioritize and rebase and reuse the work in progress. Next is ability to yield back and forth between parents and children to support layout in React. Next is ability to return multiple elements from render. And last is better support for error boundaries. So let's move on now to the next question. What is the difference between create element and clone element? So if you have seen the last interview video which we have created, so you might already know about what is React.create element, because we have discussed a lot in that video about React.create element, how JSX get transpiled into React.create element and then to a DOM object in order to be displayed in your browser, right? So we have seen all of this in our previous video, so we already know what is React.create element. But here we are getting the question about clone element. Okay, now this is something tricky. Let's see the answer for it. JSX elements will be transpiled to React.create element functions to create React elements which are going to be used for object representation of UI. So this much part we have seen in the last video, right? What is the use of create element? Now let's see the next one, which is clone element. Whereas clone element is used to clone an element and pass it new props. So simple. If you already have a element, then clone element, what it will do is it will be basically used to clone your element and pass it new props. Okay. So you can pass new props to your cloned element that you are using. So this was the major difference between them. Let's move on to the next question, which is what is lifting state up in React? Okay, this is again important question because lifting state up, this is also a kind of theoretical question, I would say. Let's understand this. So when several components needs to share the same changing data, that is recommended to lift the shared state up to their closest common ancestor. Okay, this much is very important. Let's read ahead. That means if two child components share the same data from its parent, then move the state to the parent instead of maintaining local state in both of the child components. Let's understand using this diagram. It will be very easy. So for example, let's consider these two states, these two components. Okay. So for example, just understand that every circle here is a component, okay, in itself. Let's consider these two, this one and this one. And let's say that, you know, we have a state count. Okay. We have a state count, which is needed here also and here also. Now there can be multiple options. What we can do is we can create a count state here in this component, and we can do it in we can create in this also. Okay, but what if instead of 2 our 4 components needed? Okay, so what if these 2 also needed count state? We can do it, right? But if the number of components increase which needs the count state, it is not good way to create multiple copies of your state, right? Because we know that if a state updates, the re-rendering happens, and also it is like kind of code duplication, right? So that is why what we can do in this case is we can move the state to the common ancestor. Okay, so let's go back to our situation where we want that, okay, these were our 2 components which need count variable. So what we will do is we will find their common ancestor, like which is their common ancestor. So this one cannot be as the common ancestor because this is the ancestor of this component but not of this one, right? So we will just see and we will find out that this is the common ancestor for both of these components, right? So what we can do is we can create a count state here in this case, and then from here it can be further on passed wherever it is needed, right? From here and in this way. So this is basically what is called as lifting state up. What we were doing is we were creating a state at this level initially, but we found out that this is not a better approach. So what we are doing, we are lifting our state to our common ancestor. So with this way, it will be very easy to maintain our state. Okay, so let's read the answer once again now. When several components need to share the same changing data, then it is recommended to lift the shared state up to their closest common ancestor. So this was our closest common ancestor. That means if 2 child components share the same data from its parent, then move the state to the parent instead of maintaining local state in both of the child components. So instead of maintaining the local state in both the child components, what we have done is we have lifted up our state to the common ancestor. So now I hope now it would be very clear to you what is meant by lifting state up. Okay, now the next point comes is how can we do this lifting state up? Okay, so let me tell you here itself, there are various ways, okay, with which you can do this lifting state up. First one is like prop drilling. Okay, prop drilling is the way through which you can lift your state up. There are different libraries which you can use. You can use Redux to have a common store and then put your states there, and from there you can get it. Okay, you can use context API. Okay, so all these are the ways from which allows you to get your data from a common place. Okay, so that you don't have to do prop drilling. So basically prop drilling has its own drawbacks and all. So let's now look at the question, which is what is prop drilling, because again we are already discussing about prop drilling. So why not dig deep into it and let's understand that. So first of all, let's read about prop drilling. Prop drilling is the process by which you pass data from one component of React component tree to another by going through other components that do not need the data but only help in passing it around. Now this one statement itself contains a lot of information. Okay, first of all, prop drilling is the process by which you pass data from one component to another component by going through intermediate components. Okay, for example, let's again take help of this diagram to understand this. So this is our one component and this is my another component. Now I can never pass my data directly from this component to this component because this is not a direct child of this component, right? I could have done it if this component, the lower one, is a direct child of this component above one. But in this current scenario or in our current diagram, this is not possible. So what needs to be done is if we want to pass any data from this component number 1 to component number 2, then it has to be done using this way. Okay, so this is only what is called as prop drilling. Okay, so let me mark them as 3 and 4. So if the data has to be passed from component 1 to component 2, then it has to be passed through 3 and 4. Okay, the intermediate components. Now the thing is 3 and 4 actually they themselves does not need the data, right? So for them, like it's like a confusion, right? Like not confusion for the components, but if you are doing prop drilling for a longer chain, for example, you have multiple components, you are passing it from in a long chain, right? And where if you see these all intermediate components actually do not need it. So this creates a sense of confusion, and if there is any problem in your intermediate components, your data might not pass properly. So that is what it is saying here, that by going through other components that do not need the data but only help in passing it around. So these intermediate components are the components that they themselves do not need the data, but only they are helping in passing it around from the parent to their child. Okay, so let's see the example of it. Suppose you have a top level component that fetches the data from a API. You need to display the user data in a component that is deeply nested within the component tree. So we can consider this example only. For example, this component number 1 is fetching our API data, okay, and this data that it is fetching is needed by a component which is deeply nested. For example, this component 2, this is deeply nested, right? In intermediate level also there are multiple components, so this is deeply nested. So in order to pass the user data down to the deeply nested component, you have to pass it through all the intermediary components, even if they don't directly use the user data themselves. So for example, the data that we are getting in this user is not even needed by 3 and 4, but it was needed by our component 2, so that is why we are passing it to component 3 and component 4 also. So the third point is this process of passing the user data through multiple levels of the component tree, even if some components doesn't need it, is an example of prop dealing. Okay, so this is only what is prop dealing, basically passing your data from one component to another and through by passing it to the intermediate components, whereas the intermediate component might themselves does not need that data, but they only help in passing it around from their parent to children. So now I hope you might have understood about prop drilling also. So in this video we have discussed very important questions like many. Okay, what is prop drilling? Then we have seen lifting state up. We have seen some comparison questions like create element, clone element. We have seen what is the importance of React fiber, what is reconciliation, what is diffing, right? And then we have seen what is virtual DOM, which is one of the most important questions in React.js, right? And then we have seen what is the importance of Keyprop in your React code, what is inline conditional operators, and what is the difference between HTML and React event handling. So I hope now you have got a lot of information about few more interview questions, and that too in depth. So if you have any doubt about it, please feel free to ask in the comment section and I'll guide you on it. So that's all for this video. If you are new to the channel, please don't forget to subscribe to the channel so that you get all the latest updates, and also it keeps me motivated to bring you more content like this. So that's all for this video. Meet you in next interview question video. Thank you.